In this demonstration, I'm going to give you an overview of the new SCIMAP web application. This new application allows you to run the SCIMAP diffuse pollution risk mapping tool on the website, and thus removes the need to run the GIS software on your own computer. When you log in, you're met first with the catchments overview screen. But I'd like to first point out to you that the buttons across the top, because this is your workflow as you use the application. First, you have catchments, where you can define your catchments, and this will automatically extract out your land cover, rainfall and river data, as well as the digital elevation model. You have the parameters tab, which allows you to set the parameters, the risk weightings for the different land covers. There's the observations tab, which enables you to put in a predefined, pre-measured set of observations. This might be water quality information or ecological information, which you want the SCIMAP risk weightings to be matched to. There's then the build tab. This allows you to pull together your catchments and your parameters, your observations, to put them together into a SCIMAP simulation. And finally, there's the results tabs, where you're able to see the output from the simulation that you've done. So, coming back firstly to this catchments tab, you can see here we have the digital elevation model, we have the land cover map, we have the spatial pattern of rainfall across the catchment, and this is the river network calculated from the DEM. Currently this is just set up for the River Eden, but longer term this will be set up for the full country. So if you want to create new catchments, we can click on the Create New Catchment button here, and it brings up this dialog. So what we're going to do is zoom in to the Upper River Eden. I'm going to calculate the River Emont catchment, which is this catchment here. So we can click on the drainage points where we want the catchment to be delineated from, type in the name here, so River Emont without the W, and click calculate. That goes through, runs the normal hydrological analysis on the DEM and calculates the catchment area. So we can see here that now we're happy with that, we can click save. What the system will now do is take that catchment area, clip out the land cover information, clip out the rainfall map, and to give us this kind of zoomed in area. So we now have the catchment area that we want to work on. So now if we click onto the parameters tab, we can use a set of pre-existing parameters, but what we're going to do is create a new parameter set specifically for this catchment. So we click on new parameter set, and I'm going to call this River Emont, and we're going to use the land uses from that single catchment. So we're going to use it from River Emont. So that's the one we've just classified. We're also going to simplify the land uses. So rather than using the full set of land uses, we're going to simplify them down into simpler categories, which SCIMAP can then work with. And we're going to use default parameter sets. So click on Create. That now creates this River Emont parameter set with the different risk weightings. If you want to change these weightings, if we feel that improved grassland is actually a higher risk in this particular location, we can just go in here and change that to 0.4, and then we click Save Changes. That's now part of that parameter set in the system. But for this simulation, we're going to revert that back to 0.3. I can either do that by changing the number back to 0.3, or I can click on Revert Changes. So now we can actually go through and build a SCIMAP simulation. So we go to Build. I'm going to call this River Emont as our name. We're going to use catchment, River Emont, and parameter set, River Emont. So we've got all that set up. We can now click this Run SCIMAP button. It then starts the simulations running and the calculations going. If we look in our output, we can see here that we have, now that the SCIMAP calculations have been performed, we can see them in the results window. So we click on the River Emont here to see our results, and that's then shown in the map window here. If we pull out this little plus in the corner here, we can look at the different layers. At the moment, we're looking at, we've got all of them turned off, but we can look at streams, we can look at the channel accumulated risk, which is the normal SCIMAP output. We can also dig in and look at the erosion risk potential and the surface flow. So this here is showing the erosion risk potential on a per cell basis. We can also look at the surface flow, which is often referred to as a network index, and this is the measure of connectivity across the landscape. In these examples, red represents high connectivity, as shown on the little legend over here, and blue represents low connectivity. Now we can zoom into this map to get a greater level of detail, and as we go in, the extra information is downloaded from the server. So we can see here that we've got areas of lower connectivity shown in the blue, and areas of higher connectivity shown in these turquoise, yellows and red colours. We can then look at the erosion risk potential for the same area, and we can see here we've got areas of large erosion risk related to higher, steeper slopes across the area. We can then look at the channel accumulated risk. Now this will show where there's likely to be areas of higher connectivity and higher soil erosion within these areas. So if we zoom in here, we can see one particular channel here where it's fairly low risk along this beck, but then there's a higher risk coming in along this other beck on the side here. Once we've got these, we can download the results by clicking on the download results button. That will then output it as a shapefile, which will go straight into ArcGIS. So once we've done that, we can click here to download the file. That will give you a zip file of all the outputs from this. This will also give you the soil erosion potential and the connectivity maps, again, which will go straight into ArcGIS. We can also export this directly to Google Earth. So if we click on Export to Google Earth, click again to download the file. That file's downloaded, and that comes down as a KMZ file. And once that's downloaded, we can click on that. Once the results have been opened in Google Earth, we can zoom in and look at these within the Google Earth interface. So on the left hand side here, we have the SCIMAP results. And if we want to zoom in and look at the surface flow index, we can double click on surface flow. That will zoom into the area, and we need to just make sure the little tick box next to surface flow is checked. This will then show us the surface flow index for the area. We can zoom in. We can also look at the erosion risk and use the normal Google Earth visualization tools to look at this in more detail. So say we might be interested in these valleys up here, where as you can see there's quite a lot of erosion risk coming down the steep sided valleys. But we can look at what the connectivity looks like for the same area by switching to the surface flow index. And as you can see, all the surface flow index is actually quite low in these areas. We can look at the accumulated in-channel risk, and as you can see, a lot of this is quite low risk. We've got certain hotspots where there is a combination of greater connectivity and greater erosion risk for those particular parts of the landscape. So go back and look at the surface flow index or the erosion risk, and we're able to look at this in detail within the Google Earth interface. Now, the other way in which we can use SCIMAP is to fit it to an observed set of observations. So we're able to do this using the Observations tab, and shown here is an example for the Emont catchment whereby we've created a set of observations on the different streams. To add new observations to this, you can click on Add Observation at the bottom of the screen, click on the channel where the observation was made, and you can type in the value. So in this case, we might just type in 35, click Save, and that adds the observation onto the screen. Now these observations might be of fine sediment load, it might be of ecological quality, or it might be of observed phosphorus in the stream. Now you don't just have to add these manually, you can upload an observation set based on a shapefile in British National Grid from ArcGIS, and once it's in there you can adjust and edit the observations to move them to make sure that they're snapped onto the correct channel. So to edit something, you'll click on it. You can then pick that observation up and move it to its new location. You can also edit the value here to a new value. Once you've done all of that, you then have an observation set which you can use in the Build tab. So if we go to Build, we can then do a new simulation called Emont Fitted, based on the Emont catchment, and we're going to use observations based on the Emont observations, which was the set we're just looking at, and we're going to base that on the standard SCIMAP run from the Emont. So click Run SCIMAP. What that will do is go away, do a Monte Carlo glue-based approach to fitting those parameters, and go through into the results. And you can see here you then get a set of dotty plots. Now these aren't valid dotty plots because it's a synthetic data set for the observations, but a set of dotty plots showing how the different parameters fit and what the uncertainty is on each of those. And for more details of how to use this information, if you have a look at the Rini et al. The Millage et al. Papers, which are referenced on the SCIMAP website. Okay, so that is a quick overview of all the bits and pieces to do with the SCIMAP web app and what you're able to do with it. And we hope that you find it useful in terms of making decisions about where to act within the landscape to reduce diffuse pollution pressures and improve river water quality. There's more information on SCIMAP, links to the journal papers and further training videos available on the website at www.scimap.org.uk.